Hey everyone, welcome back. So in this video, we will be discussing the design architecture of hotel booking sites. It can be Airbnb, Agoda, Make My Trip, or let's say booking.com. So again, starts with the introduction. Those who don't know about these platforms, for them, I would like to give a brief introduction. So these platforms provide you better travel experience. Using these platforms or applications, you can book a room in a hotel of any city. Let's say you're traveling to Goa. So using these platforms, you can find out all the hotels located in Goa and then you can book a room in that hotel. So this is about hotel booking sites. It can be Airbnb, Agoda, Make My Trip or booking.com. Now you can see a diagram on this screen. It seems quite complicated right now, but after watching this video you will have the enough understanding of this diagram and the tech jargons that are mentioned here. So let's get started. So again, let's say you are in an interview of system design and an interviewer asked you to design, let's say, Make My Trip or booking.com. So how would you do? How would you approach this question? So the very first thing that should come into your mind are the functional and non-functional requirements of the system that you are going to build. So in case of, let's say, Make My Trip or booking.com, what can be the functional and non-functional requirements? So the first functional requirement that we can have is a user profile. When you go to any website for the first time, you basically create your profile there. You provide your basic information, your username, password, email address, phone number. It can be anything, and on the basis of this information your profile will be created. So this is about the first functional requirement. The next functional requirement that we can have is a hotel search. So after creating a profile, you will find out all the hotels located in a particular city. Basically, you will perform a search and this search will be based on a location. So after performing a search, you will get number of hotels. So this is about the second functionality or functional requirement that we can have. The next functional requirement that we can have is get hotel details. So after performing a search, you will get number of hotels located in a particular city. Now according to your preference, you will select a particular hotel. Your preference can be anything. It can be a suitable check-in, check-out time, rate, or it can be a location. So based on your preference, you will select a hotel. So this is about the third functional requirement. Now the moment you will get hotel details, that includes different types of rooms available in that hotel. It can be a single bedroom or standard double room, or it can be the price of that room. So you will get hotel details and then you will get room details. So this is about the fourth functional requirement that we can have, which is get room details. That includes different types of rooms available in that hotel and the price of that room. So this is about the fourth requirement. The next functional requirement that we can have is room booking. So after getting hotel details and room details, now you will try to book a room for yourself. That includes concurrent booking, where multiple users will try to book a same room. So we'll see that how we can manage concurrent booking. So this is about the fifth functional requirement. The next functional requirement that we can have is a payment. So after room booking or reserving a room for yourself, then you will have to make a payment. So this is about sixth functional requirement that we can have. So we are pretty much good with the functional requirements. Now let's discuss the non-functional requirements. So non-functional requirements are nothing but the requirements that do not affect the flow of the user, but it rather affects the experience of the user. Now what does that mean? So let's say we have two hotel booking sites. I'm not taking any name. So let's say website 1 and website 2. Website 1 takes 10 seconds to respond to client's request, and website 2 takes, let's say, 100 seconds to respond to your request. So you will definitely go with website 1 because it is taking less time than website 2. So this is one of our non-functional requirement which we called low latency. Low latency means server should respond to your request in a minimal time. That means time taken by the server to respond to your request should be as low as possible. So this is about the first non-functional requirement. The next non-functional requirement that we can have is a high availability. So the system that we are going to build should always be highly available, because there are many platforms in the market that provides the same thing. So if your system will not be highly available, then why customer would select you? So this is about the second non-functional requirement. Now, how we can achieve this high availability? So for that, we will be using master slave architecture, in which multiple slaves will be there to serve your request. If one slave goes down, other slave will serve your request. So this is about the second non-functional requirement that we can have. The next non-functional requirement that we can have is a strongly consistent. Now what does that mean? So it means that whatever changes we made should persist into the database. Now let's understand this with the help of example. So let's say we have two users, user 1 and user 2, and they both want to book a room. Now let's say user 1 booked a room, so that should be immediately reflected into the database, so that user 2 will get to know that okay, this room has been reserved now and he's not able to book that room. So this is about the third non-functional requirement that we have, that is strongly consistent. But according to CAP theorem, a system cannot be highly available and strongly consistent at the same time. So how would I avoid this constraint? So for that, we will be making few services as highly available and few services as strongly consistent. Why services? Because here I'm considering this hotel booking system as a microservice architecture, in which we will be having multiple services. So we will make few services as highly available and few services as strongly consistent to avoid the constraint of CAP theorem. The next non-functional requirement that we can have is highly concurrent. Since it is a booking system, hotel booking system or room booking system, we can say, so there will be multiple users trying to book a same room. So there will be concurrent booking. So how we can avoid this concurrent booking? So we should design our system in such a way that it should handle only one request at a time. Now how we can achieve this? So for that, we will be using a different kind of locking mechanism. It can be exclusive lock or pessimistic lock, and it can be optimistic lock. So this is about the fourth non-functional requirement that we have. So we are pretty much good with the functional and non-functional requirements of the system. In the next video, we will be discussing different kind of services that our system can have. Basically, we will translate the functional requirements that we discussed into services. We'll see how we can convert those functional requirements into services in a next video. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in this video, we will be discussing about different kind of services that our system can have. Basically, we will translate functional requirements that we discussed in the last video into services. So let's see how we can do this. So the first functional requirement that we can have is a user profile, which can be translated into a user profile service, in which we will be discussing profile creation, updation of profile and deletion of profile. The next set of functional requirements that we can have is a search hotel, get hotel details, and then we have get room details, which together be translated into a search service, in which we will be discussing about searching a hotel in a particular city based on location. The next functional requirement that we can have is room booking, which can be translated into a booking service, in which we will be making a booking for a particular hotel. The next functional requirement that we can have is a payment, which can be translated into a payment service. We have few more services, that is hotel service, booking management service and archival service. Let's hold on to these services for now. We'll see them in later videos. So this is all about services that our system can have. So this is all for this video. In the next video, we will be going through with some ballpark figures to make estimations and constraints to make a choice of database and further design of our system. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in this video, we will be going through with some ballpark figures to make estimations and constraints for database choice and further design of our system. So let's get started. So according to reports, as of 2023, there are around 1,87,000 hotels worldwide with about 17.5 million guest rooms. Now let's consider a few top hotel brands, that is Hilton, Marriott and Rosewood. In Hilton, there are 1 million rooms in their 7.5k properties. In Marriott, there are 2 million rooms in their 10k properties. And in Rosewood, there are 5k rooms in their 48 properties. So let's consider Marriott because it has 2 million rooms in their 10k properties, which is a lot to cover all the required scenarios, because when we design our system on such a large scale, we see the actual issues, constraints and limitations. So let's take Marriott with 2 million rooms, that is nothing but 2 into 10 to the power 6 rooms, and there are 10k properties, that is nothing but 10 to the power 4. That means there are around 200 rooms in each Marriott hotel. So in each Marriott hotel there are around 200 rooms. Now let's calculate the QPS for each service to find out different reads and writes happen on our system. Here I mentioned few tech jargons, that is QPS, read write. So let's understand each one by one. So QPS means how many times we query database per second for information. This query can be a read query or it can be a write query. Now what does that write means? So if we make any changes in database, let's say if we make a booking, that means we are adding a new entry into the database, or we can say we are adding a new entry in booking table. That means we are making a change in database. So this is nothing but a write. And what does that read mean? So querying database for some read operations in which we are not making any changes in database. That means we are just getting information from database. We are not making any change in database. So this is nothing but a read operation. We have two major services in which we query database for booking related task. First is a search service. We have a search service, and then next we have a booking service. So let's understand different reads and writes happen on our system. So let's take read on the one side and write on the other side. Sorry for the handwriting. Now from user side, there's only one write when a user make a booking. So this comes under write category, booking. Before booking, user is searching for hotels, rooms and so on. This comes under the read part. So this is hotel search and room search. This comes under read part. Now again, let's see some ballpark figures. So in a normal hotel chain, there are 80% of room occupancy. 80% of room occupancy. So if you have 100 rooms in your hotel, that means 80 rooms will always be occupied by the users. So this is again a ballpark figure. Now let's say each user made a booking for at least 4 to 5 days. So now let's calculate booking for each day. So we have 2 million rooms, that is nothing but 2 into 10 to the power 6, and we have 80% of room occupancy, that is nothing but 0.8. And then we have let's say a user made a booking for at least 4 to 5 days. So let's consider 4. So this will be the booking for each day. Now in one day there is 86,400 seconds. So let's consider this as 100k, that is nothing but 10 to the power 5 for better calculation. So this is nothing but 10 to the power 5. So this will be 4. So this is nothing but 4 TPS. That means 4 bookings per second. So if we have 2 million rooms in our hotel and there are 80% of room occupancy and each user books a room for at least 4 to 5 days. So in each second there will be 4 bookings in our system. That is nothing but 4 TPS. Now what does that TPS means? So TPS is nothing but transaction per second. If you make any changes in database, that means you are performing write operation. So this TPS means writes per second that we made in database. So for booking, this TPS will be 4 TPS. Now let's calculate the same for read operation. So what we will be covering in read operations. So we will be covering that how many times user access hotel and room details. So again, let's consider some ballpark figures to make estimations. So there is 10% of funnel conversion, 10% of funnel conversion. That means only 10% people will book the room, rest 90% people will drop off. That means they will make a search, will access hotel and room details, but won't make a booking. So this is about funnel conversion. Now let's say we have 100 people and there is 10% of funnel conversion. That means only 10 people will book the room. And for tan, we have 10% of funnel conversion. That means only 1 people will book the room. So 1% is a conversion rate. This is nothing but a conversion rate. Now the TPS for booking is nothing but 4 TPS, and 4 is a 10% of 40 and 40 is a 10% of 400. That means for read QPS will be, the QPS will be 400 QPS. So this is how we can make estimations and constraints. So for write operation, this TPS is very low, that is nothing but 4 TPS. It is in single digit, that is nothing but order of 1. And for read operation, this QPS is nothing but 400. That means there will be 400 queries per second to access hotel details or room details. So we have 4 TPS for write operation and 100 QPS for read operation. Since this TPS for write operation is very low, that means we can say that we don't need NoSQL databases for our system, and we can have different entities in our system, and that is nothing but user, hotel, rooms. So these entities can be modeled, and since it is a booking system, 2 users will be booking a room or let's say hotel. So there will definitely be transaction related queries. That means we will have to take care of asset properties. So when it comes to taking care of asset properties, who is better than relational databases? So these estimations and assumptions helped us to make a choice of database. Since our write TPS is low and we can model our data into entities, we can have transaction related queries. That means we can go with relational database. So this is all for this video. In the next video, we will be discussing about different kind of services and the functionality of different services. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in a previous video, we went through with some ballpark figures. We made estimations and constraints to make a choice of database, and then we selected database for our system. In this video, we will be going through with the services that our system can have. But before going through with the services, let's first understand the database schema for our system. So the first table that our system can have is a user table, in which user ID will be the primary key, and then we will have username, email address, phone number, and other information. The next table that we can have is a hotel table, in which hotel ID will be the primary key. Then we can have hotel name, total rooms in that hotel, and the location in which this hotel is located. The next database table that we can have is a room table, in which we have room ID, that will be the primary key. Then we can have a room type ID. Room type ID is nothing but the type of room, that is single bedroom or standard double room, so something like that. Then we can have this inventory table that will basically store the booking for each hotel for a particular day. So this is about the inventory table, in which we will be having inventory ID as a primary key. Then we will have hotel ID, total rooms in that hotel and available rooms in that hotel, and then the price. There will be one more column in the inventory table, that is date, that will store booking for each day for a hotel. The next database table that we can have is a booking table, in which we have booking ID as a primary key. Then we will be having hotel ID, room type ID, all as a foreign key. Then we can have the price of that room that we selected. Then we have check-in, check-out time and the user ID who made a booking. So this is about the database schema for our system. Now let's discuss different kind of services that our system can have. So the first service that our system can have is a user profile service. So whenever you go to any website for the first time, you basically create your profile there. So there will be option for creating a profile. And let's say if you want to change your information, your username, or let's say your email address, phone number, so there will be option for updating your profile. So these are the features that user profile service will provide. Now this user profile service will have the authentication mechanism. Whenever a new request will come to gateway, it will first interact with the user profile service for authentication, and then it will be redirected to further services. So this is about the user profile service. I have explained user profile service in detail in system design video of IRCTC. So please refer that video for detailed information of this user profile service. The next service that we can have is a search service. This service will be responsible for making a search for a hotel on a city based on location. Now in order to understand this search service, first we will have to understand what exactly this hotel service is. So this hotel service is basically for admins. Whenever a new hotel or let's say room comes in, this hotel service will be responsible for that. That means that this hotel service will make an entry in database for that hotel or let's say room. So this is about the hotel service and the functioning of hotel service. Now let's understand our actual service, that is search service. So the search that we are going to perform will be based on location. Now it can be the case that you might not know the exact spelling of a place or location in which you are traveling. So you need some kind of database for this search service that will allow you to do fuzzy searching, or let's say filter based or wildcard based searching. So what is the database that we are going to use for our search service? So the database that we are going to use for our search service is Elasticsearch Cluster. Now how this Elasticsearch Cluster will get to know about the hotels and rooms there? For that we will be using Kafka queue. Now the question is that how this Kafka queue will get the data. So let's see how this Kafka queue will get the data. So we have this hotel service, and here we have this Kafka queue. So there will be producers on one side of Kafka queue and there will be search consumers on the other side of Kafka queue. So let's say these are the producers on one side of Kafka queue, and here we have search consumers on the other side of Kafka queue. Now the question is how this Kafka queue will get the data. So whenever this hotel service will receive any kind of update for adding a hotel, or let's say deleting a hotel, or adding a room, or let's say deleting a room, so these producers will create a payload for a particular topic. This topic can be adding a hotel or adding a room, or let's say deleting a room or deleting a hotel. So these producers will create a payload for a particular topic, and there will be a search consumer in between Kafka queue and let's say this is our Elasticsearch cluster. So there will be search consumers in between Kafka queue and Elasticsearch cluster. So these search consumers will listen to those topics that are generated or let's say created by producers, and then these search consumers will send those topics or let's say payloads to Elasticsearch cluster. So this is how Elasticsearch cluster will get to know about the data. Now, do we need any kind of cache memory? Yes, because for read operation this QPS is very high. The QPS for read operation is 400, which is very high. So what we will do, we will create a content delivery network on top of hotel service CDN. So how we are going to use this? So let's say whenever a new hotel or let's say room comes in, so this hotel service will send the static data to CDN. Let's say it can be a hotel, images of that hotel, images of room, or let's say videos. So this static data will be sent to CDN. Through this CDN, this Elasticsearch cluster will get the static data. It can be images, it can be videos. So this is about the search service that we have. In the next video, we will be discussing about booking service of our system. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in a previous video, we went through with the search service of our system. We have covered almost everything for search service. We have seen Elasticsearch cluster, CDN, how CDN will help us to store static data for our system. We have seen Kafka queue. So we have covered almost everything. We just missed one thing, that is master slave architecture. So in our system, for each service, we will be using master slave architecture just to make sure that our system should always be highly available. So if one slave goes down, the other slave will serve our request. So this is how using master slave architecture, we will achieve high availability for our system. Now in this video, we will be discussing about booking service of our system. So what are the required tables for booking service? So we will be using inventory table just to check whether the rooms are available in that hotel or not. So inventory table will be useful. Then we will be using hotel and room table. The next table that we are going to use for booking service is booking table, just to create an entry for new booking. So booking table. Now what would be the choice of database for this particular service? So we have seen that for write operation our TPS was very low. It was about 4 TPS. So 4 TPS, that means it is in single digit and order of 1. So for this booking service we can use SQL cluster. Let's say we have this client and here we have this booking service. So for booking service, since our write TPS was low, so we can use SQL cluster for our booking service. So this is nothing but SQL cluster for booking. Now in order to understand the procedure for booking, let's first see the different states of booking. So if let's say user clicks on reserved button, then the status would be reserved, but at this time your booking is not confirmed because you haven't made any payment. So this is a reserved state. Now let's say if user completes a payment, so this the status would be booked. That means your reservation or let's say booking is confirmed now. The next status of our booking can be completed. So let's say if you made a booking for 2 days, so after 2 days we will have to reflect in our system that okay, your booking has been completed now. And now let's say if you don't make any payment after reservation, you don't make any payment, so the status of your booking would be cancelled. So these are the different states of, or let's say status of our booking. Now let's see the procedure of booking. So the very first thing that you are going to do is selecting a room. This is not a permanent booking, but you have reserved your room for yourself. It is temporarily. When you will make a payment, then room will be reserved for yourself permanent. So this is the first thing that you are going to do. The next thing that you are going to do is check inventory. check inventory, whether the rooms are available or not. So if rooms are available, then only you can make a booking, otherwise you can't make a booking. So this is the second thing you are going to do. The next thing we will be doing is make payment. If let's say your payment gets successful, then the room will be booked for yourself. So if let's say payment is successful, then we will reduce inventory by 1. That okay, I have reserved this room, so reduce this available rooms column by 1. And let's say if your payment is not successful, then the inventory will remain the same. So this is the procedure of booking a room in hotel. Now what if I want to fetch my previous bookings, or let's say completed bookings? So my booking data is in this booking SQL cluster. So can I use this same cluster for fetching all the completed bookings? Actually I can, but I will not, because the QPS for read operation was very high. It was about 400 QPS. So I'm not going to use the same booking SQL cluster for fetching all the completed bookings, because it will increase the burden on our SQL cluster, booking SQL cluster. So for that we will be using another service, that is nothing but booking management service that we discussed in previous videos. So let's see how we can achieve this. So for write operation, we are going to use this booking service. For write operation, we are going to use this booking service. Let's say I want to create a new booking, so I will be using this booking service for that. And for read operations, let's say if I want to fetch the previous booking details, so for that we will be using this booking management service. Booking management service. So let's see how we can use this. So let's say we have this client, and this is the booking service we have. Now we are not going to use the SQL cluster for fetch operations for fetching previous bookings. So this is our SQL cluster. We are not going to use this booking SQL cluster for fetching completed bookings. And here we have this booking management service. This booking management service will be responsible for all the read operation, or let's say fetching the details of completed bookings. Now we need some kind of storage system to store these completed bookings. So for that we will be using Redis cluster or Redis cache. Now let's see how we can use this. So this is our Redis cluster. Now whenever user wants to fetch a particular booking, so first he will check that in Redis. If it is available in Redis, then he will fetch that from Redis, and if it is not available in Redis, then he will fetch that from SQL cluster and add an entry in Redis for future use. So this is how we can reduce the burden from SQL cluster and reduce the latency. Now when your hotel will be new, the traffic will be low, or let's say booking will be very linear, but after some time there can be exponential growth in the bookings. So the right TPS for our booking service is nothing but 4 TPS, and that means 4 bookings per second, and there are 86,400 seconds in a day. That is nothing but 10 to the power 5 seconds. So there will be 4 into 10 to the power 5 bookings per day, and for 100 days your booking would be 4 into 10 to the power 5 into 10 to the power 2. That is nothing but 4 into 10 to the power 7. This is nothing but the booking for 100 days. So you can see how rapidly it is increasing. So is it good to store the data for completed bookings in same SQL cluster? Obviously not. In future, there will be a time when this booking data will reach the SQL database limit. So what we can do to overcome with this problem? Now my question is that, is it necessary to keep all the data in same SQL cluster? Actually no, because if your booking has already been completed, then what is the need to store the same booking, completed bookings in the same SQL cluster? So for that, for completed bookings, we can use NoSQL database, something like Cassandra, which are meant to store such huge amount or huge volume of data. So we will be using Cassandra for storing completed bookings. In previous videos, we have discussed about one more service, that was archival service. So this archival service will be responsible for fetching all the completed bookings from booking SQL cluster, and then this archival service will move these completed bookings into NoSQL database, that is nothing but Cassandra. So this archival service will fetch all the completed bookings from booking SQL cluster and then move these, or let's say dump these completed bookings into Cassandra. So this is how we can reduce the burden from database and reduce the latency for our system. So this is all for this video. In the next video, we will be discussing about some concurrency issues that can occur in our system. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in this video, we are going to discuss about some concurrency issues that can happen in our system. So the first issue that can happen is when the inventory size is available. That can create a double booking problem. So let's try to understand this with the help of example. So let's say we have this user with ID U1, and this user with ID U1 creates a booking of room at time T1 for room ID 123. Now our system, let's say our system doesn't redirect this user to payment page. So in frustration, this same user with ID U1 at time T2 will create another booking for same room ID. So this is nothing but the double booking when the room ID is same, user ID is same check-in check-out time. So this is nothing but the double booking. So how we can overcome with this problem? So there are two ways to overcome with this problem. First is making a button as disabled, make button disabled. That means after first click, we will make this button as disabled so that user won't be able to click on that button again. So this is how we can overcome with this problem on front end side, and on the back end side, we can overcome with this problem using idempotent API. That means for the same request, if it hits multiple times, then server is going to send the same response. Let's try to understand this with the help of example. So let's say we have this user and it sends R1 request to the server. So this is our server, and then server respond to its client's request as res1. And let's say if this user sends R1 request again to server, then server is going to send the res1 response again. So this is nothing but idempotent API. Using these options, we can overcome with this problem. The next concurrency problem that we can have is a race condition when two users will try to book the same room. So how we can overcome with this problem? So for that, we will be using pessimistic lock, or let's say exclusive lock, in which user won't be able to read or write something in database. So this is how we can overcome with these concurrency problems. So this is all for this video and for this playlist. In next videos, we will be discussing the design or architecture of few more interesting systems. So till then, bye bye, show some love, thanks.